Let us move further for the calculation of packing efficiency in body-centered cubic unit cell. This is our body-centered cubic unit cell. Here E is the atom at the body center. This is the body diagonal AD. So the distance between the two closest atoms in such a structure is AE or ED. So D, that is the nearest neighbor, is equals to AE equals to ED or AD by 2. A is the edge length, as we all know. Now let us consider this triangle ABC. By applying Pythagoras theorem, we will find that AC square is equals to AB square plus BC square. Now AC square equals to A square plus A square, since AB and BC both are the edges and edge length is equals to A. Therefore here it should be A square, here it also be A square, and AC square will be 2A square, and AC equals to root 2A. That is the length of phase diagonal is root 2A. This is our equation number 2. Let us move further. Now we consider the bigger triangle ACD. The bigger triangle ACD is this one, ACD. We are considering this triangle where AD is the hypotenuse and the other two sides are AC and CD. So again we are applying Pythagoras theorem. So AD square equals to AC square plus CD square. AD square equals to AC square is 2A square. In equation number 2, we have seen that AC square equals to 2A square. So we will place here AC square equals to 2A square, and CD is again edge length, so it is A square. So AD is finally equals to 3A square and AD equals to root 3A. AD is a body diagonal, so the length of the body diagonal is root 3A. Now since D is equals to AD by 2, therefore D is finally equals to root 3A by 2. So the distance, if we want to calculate the nearest neighbor distance in body-centered cubic unit cell, and if we have this A edge length, then we can easily calculate it by this formula. Further, it should be noted that the particle at the body center touches the particles at corner along the body diagonal. It is shown here. Let us say that AD is the body diagonal and this is the atom, body centered atom, and these are the two atoms which are placed at the corner. So the diameter of the body centered atom is 2r. The radius of this corner atom is r, and the radius of the another corner atom is again r. Thus from here AD can be equals to r plus 2r plus r, that is equals to 4r. Now from equation number 3, this one, and equation number 5, this one, AD is here root 3A, AD here is 4R, so we equate these two, root 3A equals to 4R. Now we can easily able to calculate the relationship between A and R. A is 4 root 3R. From equation number 4 and 6, this was our equation number 6 and this was our equation number 4, D. From equation number 4 and 6, D can be again equals to 2R. How? Like D equals to root 3A by 2, and if we place the value of A from equation number 6, we will get 4 by root 3R. Then root 3 cancelled and 2 will be cancelled by 4. Then finally we will get 2R. D is equals to 2R again here. Now the volume of the unit cell is A cube. From 6, the volume of the unit cell is 4 by root 3R whole cube, because the value of A is 4 by root 3R. Therefore 4 by root 3R whole cube, and it will be 64R cube by 3 root 3. The number of atoms in body-centered unit cell is 2. We know that number of atom in a body-centered unit cell is always 2. Therefore the total occupied volume is 2 into 4 by 3 pi r cube. 4 by 3 pi r cube is the volume for one sphere. So if there are two spheres, then 2 into 4 by 3 pi r cube will be the occupied volume. It will be 8 by 3 pi r cube. Thus packing efficiency is again occupied volume into 100 divided by total volume. So this is our occupied volume, 8 by 3 pi r cube, and this is our total volume, 64 r cube by 3 root 3. So it will be here, and by all calculations we will get that packing efficiency is 68% in body centered cubic unit cell.